Hello, my name is Joe Hedrick, and welcome to A Civil Engineer's Guide to Navigating Autodesk Inventor and the Infrastructure Parts Editor. There are four objectives to today's presentation. One, to learn how to use the Infrastructure Parts Editor to modify existing part catalogs and to create new ones. Two, to learn how to create parametric part shape models inside of Autodesk Inventor. Three, to learn how to export parts created in Infrastructure Parts Editor for use in Civil 3D and/or InfraWorks. And four, to learn tips and tricks for this overall process so that you don't make the same mistakes that we did. Let's take a look at the Infrastructure Parts Editor. Infrastructure Parts Editor, or IPE as I will refer to it from this point forward, was created as an alternative way to author Civil 3D content as well as a way to model content for InfraWorks. If anyone has tried to create gravity pipe structures in Part Builder, I'm sure you will agree with me that any other way is an improvement. While this was a labs project for Autodesk, it was named Project Chameleon. I only mention this because depending on what version of the tool you use, some of that legacy naming is still present. Now, without further ado, let's jump into the software. IPE is launched from either inside of InfraWorks or inside of Civil 3D. In our case, from the Civil 3D Home tab, we will click on Create Design, and you'll see there's an entry for Infrastructure Parts Editor. When IPE opens up, it's a fairly simple application. There's three tabs across the top: Catalog, Parts, and Publish, and a couple of options along the left-hand side. If we take a look at Open My Parts Lib, that's going to show kind of the main area to get to the content. Alternatively, Recent is going to show you just that, some recently used libraries. But for when you're just starting off, this is the area that I would direct you to go to. Now, there's two different types of parts that can be created. IPE calls them domains. Drainage structure is just that. These are gravity drainage structures that can be used in Civil 3D or InfraWorks. Piping is a little misleading. Piping does not do Civil 3D pipes. We still need Part Builder, if we need to modify any of the pipe catalogs inside of Civil 3D. What piping is in this case is for pressure pipes and all pressure pipe content. So the pipes themselves, as well as any of the appurtenances and fittings. So from drainage structures, you'll see that there's four out-of-the-box catalogs that ship with Civil 3D. They're almost kind of duplicates of each other: generic drainage, Imperial, generic drainage with pipe connections, Imperial, and then the equivalent metric counterparts. The difference here is a couple of years ago, Autodesk introduced this concept of connection points with these parts, and that's really become the main reason why people embrace creating gravity parts this way, is because we can now separate where the pipe connects on the structure from its insertion point. Historic Civil 3D points, or Civil 3D structures, the insertion point is 99 out of 100 times in the center of the structure. That's where the pipes connect. There's nothing really we can do about that. With the pipe connections, however, now we're able to say maybe have a curb inlet whose insertion point is along the back of the curb. However, the pipes still connect to the center of the structure itself. Or another example would be maybe there was a large structure and we wanted to have multiple pipes connect to it along one side. We could do that with adding multiple pipe connection points to it. What I recommend to get started with this is to really dig in and look at the content that Autodesk has provided. So what I would recommend is maybe go into generic drainage with pipe connections, double click on that, and what that's going to do is that's going to open up, that particular library. Now, at this point, what we don't want to do is, kind of monkey around and, make modifications to this one. So what I always advise people to do is as soon as you open an out-of-the-box library, immediately do a save as, and then you've got something that you can play with and without fear of really mucking anything up. So to do that, we click the little Save As button. Right from here, we can give it a name. Maybe we'll just call it Test. Specify the catalog description. Now, the catalog description, ironically, is what's going to show up in Civil 3D when you pick the library. So keep that in mind. And we'll say OK, and it's going to go ahead and basically make a duplicate of that library for us to use and play with. Now, inside of this, down at the bottom left-hand side, it's divided up into structures and assemblies. We'll start with structures, and there's three main types of structures. There are grates or covers, there are underground structures, and then there's what we call surface structures. Now, grates and covers are pretty self-explanatory. They're exactly as they sound. Underground structures are the part of the structure that's going to be below ground, hence the name underground structures. The surface structure is the part that is above ground. And the way that this works is, each of these, components are modeled independently, and then we can snap them together as we need to create the parts that we're looking for. We've modeled, many libraries for, states and independent and individual companies, and it seems like, there are so many times where there are several parts that are slight variations on each other, right? It could be a square box with, maybe just a simple curb inlet on the top of it, right? And then a variation of that part would have, maybe an extra wing wall coming off one side. Another variation would be that wing area would come off of the other side. Another variation would be, the wings on both sides. So, this mechanism is ideal for parts like that because we don't have to keep remodeling the exact same parts over and over and over again. We can just model the differences and then at the end snap them together like Legos. So the way that this does work, and like I say, explore with this, tear it apart and see what Autodesk has done. You can really learn a lot. But there's a couple of tabs across the top for any of these part shape families. The shape itself is the Inventor template, right? We'll talk in a little while about all those different variables that were just on the screen and what they mean. But if you wanted to look at exactly how Autodesk did this inside of Inventor, all you simply need to do is right-click and select Export, and then that's going to export an IPT file that you can then open inside of Inventor and see exactly what they've done. So hitting Next, moving through under Detail Properties, a lot of people will tell you that you only need to fill out the part family global name, and that would make some sense because there's a green dot beside it. However, there's actually another area of this that you have to fill out. You have to fill out this inlet form, right? We have to tell it whether it's rectangular or whether the structure is going to be round. So everything else is optional. The next part of this is the part size, the available part sizes. And you'll see there's a lot of information here. This particular piece is fairly simple. It's only got really one size, 36 by 36. But as we move across to the right, the good rule of thumb is if it has a star, then it needs a value. So you'll see there's a lot of variables. Here's where we're telling it it's 36 by 36, inlet opening height, curb height, things like that. If we wanted to add a row, we simply select Add Row, and then we can come through and add, maybe we wanted to do 48 by 48. This size is how it's going to show up inside of Civil 3D. So maybe we wanted to do 48 by 48. Right, and I'm just going to accept some of the other defaults there, but we get the idea of how this works. Now what will happen is whenever we go to match this part onto an underground structure, it should match up to an underground structure that's either 36 by 36 or 48 by 48. Finally, under part size validation, this is where you actually get to look and see what the shape's going to look like, right? So if I were to click on this 36 by 36, we get a preview over here of that particular inlet, right? We can see the different areas. This green area, or this green arrow, is for the is the matchup for the grate or cover, and then this green arrow down here is where it's going to line up and match onto the underground structure. So again, 48 by 48, you can see it's just kind of the same thing, just a little bit bigger. And that's really all there is to it. So we create these for the surface structures, we create these for underground structures, and maybe let's take this this quick rectangular base, exact same thing, name it, shapes, there it is. You can export this if you want to. Because we have to give it a structure-based form. Again, this is whether it's round or rectangular. Part editing, this one has multiple sizes. If you get into a situation where you need to add a whole bunch of different sizes, you can export this to Excel, add your sizes in Excel, and then import it back into this. It really makes it a whole lot easier to do that. But when it comes to validation, again, the exact same thing. We can click through and see the different underground structures. Now, at the end of the day, what happens is, the grates, the surface structure, the underground structure, all gets matched up into, the overall what this calls an assembly. Right? Not to be confused with corridor assemblies. They're a little bit different. But if we take a look at this one, we can see that the base part, the surface structure controls everything. So you always pick the surface structure first. Here's the name of it, right? We hit next, and what this is showing is that it doesn't completely match all the sizes. So there's some either available sizes that exist in the underground structure that don't exist on the surface structure, or vice versa. However, what this will do is at least allow us to match up the ones that do. Over here on the right, that's what the triangles stand for. If there is no triangle, then it matches 100% all sizes on both pieces. Right? We look at the detailed, and then finally size validation, and we can see here's the area where it's having trouble with is those last frame heights. But again, clicking on it, we can see the completed structure, all three pieces. And at the end of the day, when we're done with it and ready to publish, we would go to the Publish tab. We would select Publish. It's going to ask me if I want to save it. We'll go ahead and hit yes. It's going to ask what assemblies do I want to publish, right? I don't have to publish everything. So I can select none. I can only pick a couple if I wanted to. The next thing it's going to do is ask me what product or products do I want to publish to. We can publish to InfraWorks, or we can publish to Civil 3D. Again, it'll tell you if there's any warnings. And again, it looks like it's complaining. short descriptions are empty, and that's okay. It's only a warning. It's not an error. But at the end of the day, we would hit OK, and it's going to publish to Civil 3D. All right, let's leave the software for just a few minutes and start to look at modeling our own parts. What happens when we have a situation that there isn't an out-of-the-box structure provided by Autodesk? Right? And the way that we do this is through Autodesk Inventor. And what I tell people, there's 5 things that we need to do first. And the reason I say that is for most of us, Inventor is kind of a foreign product, right? We can use Inventor or Inventor LT to model these infrastructure parts, but historically, civil engineers haven't really had a need to mess with Autodesk Inventor. So the first thing that I would recommend for anyone is review some videos, get a little bit of training. I truly promise it will help ease some of your frustrations. So the 5 things that I always recommend to do first is once we get into the Inventor environment, we need to change what the software views as the top, right? Inventor will, have its axis that's slightly shifted from what we typically look at with Civil 3D. And if you don't make this change, then all of the parts that you create when it comes time to insert them into Civil 3D, they'll be laying down on their side. So that's definitely one that we want to do. Number 2, review the essential skills videos in the Inventor help. Right, Inventor, like I said, it's 3D modeling. If you do have experience with Part Builder, you will actually be kind of a step ahead, just because a lot of the same concepts come across to Inventor. The idea of planes and sketches and extrusions and lofts, those are all concepts inside of Inventor that we're going to need to know about. And these videos will help get you on your way. The next thing that I would recommend is reviewing the part authoring videos in the Civil 3D help. It's kind of embarrassing that when I first started doing this, I couldn't get anything to work. And I called a friend of mine in Autodesk development, and I'm like, man, does this really work? And he said, well, yeah, it does. Have you read the help? And yeah, I hadn't. So I kind of got embarrassed there. But inside of the help, there are some good part authoring videos that run through, simple modeling techniques, on, manholes and catch basins and things like that. The 4th thing I recommend is review the parameters. You will hear me say this for the remainder of this session. It's all about the parameters. They will make or break your success with this. The parameters are essentially all these little variable names, and they have to be exact. They are case sensitive. If you misspell one, it's not going to work. If you don't use one, it's not going to work. So it is truly all about the parameters. And then finally, I say plan your modeling session. Get a look at the typical detail of the structure that you're going to be creating and kind of plan out how you're going to model that. What portions of it are going to be the surface structure? What portions of it are going to be the underground structure? How can you break that up? The other thing that I would say, think about what application is the part going to be inserted into. 9 times out of 10, that answer usually is Civil 3D. And keep in mind that Civil 3D does a great job of showing, the structure in plan view, profile view, cross-section view, but we don't need to model it to the nth degree because we'll never see some of that detail inside of Civil 3D. So keep that in the back of your head. You don't need to model every nook and cranny of a structure, right? You certainly can, but what we found is down the line, it kind of becomes just wasted time. All right, you've heard me say it's all about the parameters, and here's an example of the parameters that I'm talking about. And instead of looking at it like this, let's take a look at let's take a look at these these different help areas that I've been talking about. In the Inventor side, here's exactly what I'm talking about with the Inventor Essentials videos. Just how to navigate. Getting around Inventor is very different than getting around Civil 3D. Sketches, creating different parts and whatnot. All of these are going to really help you, start to navigate Inventor. Right? From the Civil 3D side, there's a whole section on infrastructure content authoring, part authoring basics. Here are the videos, Inventor part modeling. So you can see that there's certainly a handful of different examples, that Autodesk provides. But finally, there is this parameters reference, and there is a lot to this as we go down, and a lot of it depends on what type of structure are we creating. So if it is a surface structure, pay special attention to anything that it says that's required. Right? If it says if it is required, it's for a reason. And 9 times out of 10, if you don't have a value or if that variable doesn't exist, then it's going to fail when it tries to export. Also pay attention to down below, right? Some additional parameters that may also be needed. Right, this is all really important stuff to make sure that you get inside of the model. All right, so enough of that. Back into our last slide. Plan out the modeling session. So this is the part that we are going to model, and it's a City of Houston, Type C inlet. You'll notice that it is not the world's most complicated inlet. I recommend, starting off, relatively simple. Get the hang of this. Start to understand how it works. Right? I promise you, you're going to end up modeling the same part a couple of times before it works. So start small. Pick something easy. In our case, it's a rectangular inlet, 48 by 48, 36 inches tall, 6-inch wall thicknesses, and a 6-inch base. So without any further ado, let's take a look at how we model this inside of Inventor. Here we are inside of Inventor, and what most people do and how I recommend telling people to get started is the first thing that we want to do is model a part. So we can select part, and what's going to happen is Inventor's going to take just a minute to load what it needs to load and get ready. And the very first thing that you'll notice is, number one, we don't see anything, and that's okay. Notice down here at the bottom left-hand side, where our essentially the UCS icon is, and you'll notice this looks pretty good, right? We're looking straight down at Z. X is pointing up, or X is pointing to the right. Y is pointing up. And what a lot of people do when they're first getting started with this is they'll just start modeling. However, I mentioned in my top 5 things to do before you get started is we have to change this view. Because if you'll notice our little view cube over here, we'll notice that look is actually from the front of the part. And we need this particular orientation, basically Z coming off the page. That needs to be the top and not the front. And so the way that we do that is just by hovering over the view cube. We click the little context menu, And what we can do is we can set current view as top. Right, you'll see now that that view cube has changed, and that's really all we need to do. Now, what I recommend doing at this point is, take this just so that you don't have to remember to keep doing this. Do a save as and save this as a template, and that way, as you create new parts, right, this is going to already be done for you. It's the same concept of creating a Civil 3D template so that it contains all of your styles and layers and colors, all of that information. Same idea here in Inventor. So just to show what that would look like, I'll say create new. I've got this this template that I created called IPE, and I'm going to create a part based off of that. All right, so just to avoid confusion, let's get rid of that old one. And really what this is looking at, notice that it's showing me my top, looking right down the Z-axis, and all that's different here is I have turned on the XY plane inside of Inventor. And so we're going to use that. We're going to use these different planes and create more of them. So definitely planes, extrusions, get used to working like that. So to draw anything in Inventor, we ultimately need to start with a sketch, and that sketch is going to go on a plane. I'm going to go and just noticing my view cube here. Let's flip that around just a little bit to where we're looking at it like civils would typically expect. And let's draw the outside of this underground structure. And we'll say, let's do kind of a 2-point rectangle, and we'll kind of constrain it to the center here. And this is where some of these variables are going to start to show up, right? So I could come in and say 48 inches by 48 inches, but that wouldn't allow for any variations, right? What if I had some that was 36 by 48, 24 by 48, right? I don't want to have to model this multiple times. So that's where these variables start to come to play. So we will do US length, right? And US length is underground structure length, right? Notice, number one, it has to be spelled correctly. And number two, it has to be, the capitals and the case matter. So US length, and then this is going to be US width. And just like that, we have created a 48 by 48 square. Now, let's offset for the wall thickness. So we'll go ahead and do that. We'll create this offset. We'll click on that, kind of pull it in a little bit, and introduce another variable, wall TH. We'll say that equals 6 inches. And we'll finish our sketch and zoom out. So essentially at this point, we've just created 2D geometry. However, now what we can do is extrude this. And I'm going to tell it that another variable is going to be underground structure height. Right? I always have a hard time spelling height, and I promise you it won't work if it's misspelled. But US height, and I don't want to extrude this to the top. I actually want to extrude this to the bottom. I have always had the best of luck with this working, basically where the structure is going to connect to the surface structure and then modeling down. So US height equals 36 inches. We'll do that. And, essentially what we've got now is, just kind of a hollowed out rectangle. But what we'll do is we need to start working on this bottom plane now. So let's create a plane there. And we'll say, let's create an offset of 0. Now, what Inventor does is it just starts to call these planes work plane 1, work plane 2, work plane 3. I like to rename those just a little bit to make it, a little bit easier if I have to come back and figure out what I was trying to do. So I might want to call this structure bottom or structure interior bottom, just so that I'll know, what it is, right? So let's start another sketch on that. And what we will do is let's project some geometry. And we'll say project geometry. We'll want to make sure that all of that is highlighted for the projection. And that's going to be really all that we have to do there, is now that geometry exists down on this particular work plane. And let's extrude this, both pieces. And what we're going to do is introduce another variable, base th equals 6 inches. And we'll say OK to round out the bottom of that. So if we take a look, notice now we've created just the inner core or the underground structure, for this City of Houston part. Now we're almost done. So let's come back up to kind of the home view. There's two more things that we have to do. The first thing we have to do is tell Inventor when this thing exports, what parameters do we want to export. And we need to add a couple of more parameters to it, right? Because remember that, back in my parameter listing for, if we find for underground structures, right, it's going to say that, hey, the XP prefixes are, they're necessary. SP length and SP width are required for rectangular underground structures. So with that being said, we're going to need to create some more of these variables. So I'm just going to add a numeric, SP length, and let's add another numeric, SP width. And come over here, and again, instead of hard coding those, I'm just going to make this set to US length and US width. Right. Now, the next thing is we have to determine what do we want to export out. And the way that we do that is in this key column by selecting the variables. Essentially, all of the required variables need to be selected. There's a couple of schools of thought on this, but anybody that I've ever watched do this, model parts like this, always go through and select this export parameter, column 2. I've been told that you only have to do the key column, but it seems like everybody seems to do both columns. I will tell you it certainly doesn't hurt anything to do both of the columns. So we're going to hit done, and what I'm going to do now is I'm going to start turning off a couple of these planes. Right, this one right here, definitely we'll just change its visibility to 0. I'm going to need this one for just a second longer, so I'm going to keep it turned on. And we're going to go into the Environment tab, and we're going to select Infrastructure Part Shape Utilities. And this is really where a lot of the magic happens, right? Because what we need to do is we need to tell Inventor, right, how to match these parts up. And that is done through this thing called an Assembly connector. So if I select Assembly connector, the port name is going to be Underground Structure Port. Right. The only other that this could be is grate or cover, but when we go and as soon as you start typing, U, it kind of fills out the rest of it. And what we're going to do is Inventor has this concept, the center point of the loop of edges. So we're going to select the plane, and we're going to select the loop of edges. And we're going to make sure that the little green arrow that gets added is pointing up, right? Because it's going to connect, to the corresponding one on the surface structure. So that being said, we'll close this out. I like to hit finish just to make sure that everything kind of writes and it gets taken. Let's go back into the part shape utilities. Again, we see that our little arrow is still there, our little connector is there. And what we're going to do is we're going to export this template. Right now, before I do that, I'm going to hit close here. Kind of go back in there and let's turn off this work plane. And the reason that I'm doing that is this is going to create a little thumbnail image, and I'm just trying to get that plane out of it. So just to make this image as kind of as clean as it can be right here. So it's going to ask me to select a folder. This is the default locations, and again, you kind of see that chameleon terminology show up here. But what I'm going to do is I'm going to call this COH base 1, maybe COH type C base 1. And hit OK. Right? And what that does is that goes ahead and exports the part. Notice that it has saved it now, and I am working in that saved model. And that's really all that we have to do for the underground structure, right? We can finish this, we can get out of it, we're essentially done. All right, back in Inventor with a new part started from my template. Let's go ahead and model the surface structure really quickly. And again, this is going to be kind of variations on the same theme. It's somewhat repetitious. We're going to start with our plane. I'm going to have to start a sketch, attach it to that plane. Let's draw a rectangle. Right now, this is going to use similar variables, but not the exact variables as the underground structure, right? So underground structure was US length and US width. This is surface structure, so this is going to be SS length and SS width. Right, that's all that we're going to need for the beginning of this. If we were to go back and look at it from a 3D view, let's extrude down. The height is 10 inches to begin with, based on our standard detail. So we will extrude this. We're going to add another variable at this point. It's going to be SS height. Equals 10 inches. And again, I don't want to extrude up. I want to change because again, I have the best luck starting at the connection and working down from that. So SS height equals 10, right? And we'll model out the actual opening for the curb inlet here in a moment. But let's go ahead and get the riser and the wall thicknesses going. So let's tip it up on its side. We're going to offset this 0. And maybe instead of work plane, I'm going to call this riser top. And let's start another sketch here. And what we'll do is project that geometry. Once we have done that, let's offset that geometry. And what this is going to be is for the wall thicknesses. So again, wall TH equals 6 inches. And this particular riser is about 6 inches. So we'll finish the sketch and extrude that portion of it. Right. And for distance, we will just say riser height equals 6 inches. All right, so that's starting to look pretty good. If we kind of tip it up, you can see what we've got. We've got a solid portion up here. Right, this plane will be the plane that connects to the underground structure that we just created a minute or so ago. So let's get a plane there, because I'm going to need to ultimately have a plane at the bottom of this. So let's just do it while I'm thinking about it. And again, let's rename that to riser bottom. And go back and look at this and an isometric view. All right, so next thing we need to do is let's do kind of a fillet across the top, you know, for the little rounded edge. So that's pretty easily done with the fillet command. And we'll pick that edge right there. We're going to tell it that, you know what, we can just hard code this one. There's no reason to, you know, to have variables there. And now the next thing we need to do is start a sketch on this front plane. So we'll start a sketch on this. Let's draw a rectangle. And what I'm going to do is kind of lock and constrain this to the inside of the wall thickness. So I'm going to call this curb opening. Oops, let's try that again. Yeah, so we're going to call this curb opening length equals, and I want this to be kind of dynamic and parametric with the part. So what I'm going to do is I am going to say that it is essentially SS length minus 2 times the wall thickness. And we'll create another variable, curb opening width. And I'm just going to say in this case it equals 6 inches. All right, so we'll finish that sketch. We can see my my curb opening there. Let's do one more extrusion to kind of finish this up. And again, this is going to be, I want to extrude it essentially the width minus a wall thickness. And we'll flip this and have it go the other way. And just like that, let's turn off a couple of these some of this visibility. We're going to need that last one, but if we were to look at this, you can see that it's kind of hollowed itself out, cored itself out accordingly. Oops. Right, so just like before, we need to go into the parameters. We're going to need to create those same SP length and SP width. Consequently, if this were round, it would be SP diameter would be the parameter that's required. This is going to lock to SS length and SS width. Right, so again, let's go through these exports. Now, I don't need to export, you know, the curb opening length and width unless that's going to be a parameter that you want users to be able to adjust inside of IPE. right? So in this case, these parts they don't have a whole lot of various sizes, so I don't need to do that. But if this is something that, it does need to adjust the different, size openings, we can absolutely export these and have control over them inside of IPE. The riser height isn't a required parameter, but it's not that one. These three are. So again, just like before, we'll come through and get both columns. We'll hit done there. We'll go into the environments, shape parameters, and now what I need to do is I need to put that assembly connector, but I need to put it on the bottom, right? Because it's going to connect from the bottom of this thing. So let's twist this around just a little bit differently. There we go. And we'll say assembly connector. This is going to be an underground structure port and from a loop of edges. So I'm going to click the plane, click the loop of edges. We'll see that it knows it's pointing down. So that's exactly the way that it should in this case. Right? Again, I like to say, finish. Now we can click on this plane, close off its visibility or turn off its visibility. Go right back into the environment. We'll see that the structure port's still there. So all we need to do is export the template. We're going to call this City of Houston. Type C, surface structure. And hit export. And close. And we are done inside of Inventor. Right? We have created both parts. I did cheat a little bit in that I didn't create the grate on top, or for an opening for that grate on top. Right? Again, this goes back to, think about what product this is going into. Civil 3D is really not going to display all that detail, so why waste time modeling it? Here we are back in IPE, and what we're going to do is create a brand new catalog. Then we are going to bring in the surface structure and the underground structure. We're going to combine those two into an assembly, and from there we'll export the library to Civil 3D and then test out the part to make sure that it works. So the first thing we're going to do is come down to New, and let's create a structure library. So catalog, I'm going to call this COH for City of Houston. Specify catalog description, City of Houston. And keep in mind that this catalog description is what is going to show up inside of Civil 3D. We want to make sure we get the right units, but we'll say OK. And the very first thing we need to do is under surface structures, we're going to right click, select new. Let's call this type C. Actually, let's put a space in that. Right, again, the surface structure is what controls everything. So we want to make sure we pick new shape template, that we go and we pick, what we exported. So we're going to select that. We're going to hit next. Again, this is going to be the overall family name. We saw it give me a warning, before about not having a description. You don't have to have a description. However, a short description, if you don't though, you will get that warning when it goes to try to export. And then we do need to tell it that it is rectangular inlet. Right, from here for sizes, let's add a row. This is how it's going to show up inside of Civil 3D. So we might say type C 48 by 48 size. And then again, it's really only the starred ones that you have to fill in, right? So this would be all of the different size variations that we have, one row at a time. And again, if you've got a whole bunch of these to do, save yourself a load of time, export this to Excel, do your work in Excel, and then import that spreadsheet back into this. It is a huge time saver rather than messing with this particular interface. So the height is 10, wall thicknesses are 6, 48, and 48. Right, now in my case, I'm only going to do one size, But when it comes over to the validation, you can see, our opening, our part, that all looks pretty good. So we're going to select done. And that is our surface structure. So now let's go do the underground structure. So we might call this type base 1. Hit next. We're going to go point to that Inventor library. So that's what I exported right there. We'll select that. We'll hit next. Again, type C base 1. And then we have to give it a size, whether it's rectangular or round. Let's add a size. All right, US length 48, width 48, wall thicknesses are 6. It was 36 inches high, 6 inches, 48 and 48. Right, we'll hit next. We'll validate that size, and we will hit done. All right, so I've got both of them in there. The last thing we need to do is pull it all together. So we do that in an assembly, and it's going to be an inlet. Again, the surface structure is what controls here. So we are going to select the surface structure. We're going to give it an assembly property name now. So we can call this type C. Now, I'm going to do this for a reason because it's a pretty common mistake. A lot of times people will hit next and this whole window shows up blank. And the reason for that is because technically nothing's selected in this interface, right? You have to actually pick on it and then hit next. And what you will see is the surface structure. And now it's going to show me all of my available underground structures. And it's pretty much going to ask, or is asking, okay, what do you want me to snap together with, right? You'll see because we've got the sizes correct, I don't have the triangles, I'm not worried about that. And we simply just drag this over and drop it into place. Because I didn't model in any grates or covers, that's showing up with the red circle. We'll hit next. Again, give it a short description. We'll hit next. There's the size validation, and you can see that it has indeed snapped those together. That looks really good. And at this point, we are pretty much done. There is our completed modeled part. So we will go through and do this for all the parts that you're trying to to model. But ultimately, we're gonna do a publish. So I'm gonna hit OK here to save it, and it's gonna ask me again. I can pick through the ones. So I want to do this type C structure. It's going to ask me where do I want it to go to. Let's not worry about InfraWorks. Let's send it right to Civil 3D. It's going to write all of these files to the correct location. It will tell you if it succeeds or if it fails. So don't get discouraged if it fails the first couple of times. You have to get the parameters right. So from there, we are done inside of IPE. The catalog is available inside of Civil 3D, so let's see what that looks like. All right, finally back in Civil 3D, let's see the fruit of our labor. And the first thing we're going to do is pick from Create Design, and we're going to set the pipe network catalog. And again, I want to make sure that we're pointing to that City of Houston catalog that we created. So let's create a part list real quick, and let's just call this IPE. We'll just add a quick pipe size. "12 inches should do it. For the structures, here is our Imperial structure, that Type C Imperial that we created. So let's add that. And when we go to add sizes, we only add one size, so that's why we don't have any options here, but we see our 48 by 48, so we will add that. Let's pick a decent style here so we can see this thing in action. We'll say OK there and hit a quick save. Let's do a pipe run. So we'll do pipe creation tools. We will base this on that IPE part list. Pick our surface, say OK. And what happens is up here, we'll see type C imperial. And let's just place a couple of those structures. And come on, here we go. We'll highlight these and take a peek at them in Object Viewer. Right, and we'll see that we do indeed have the appropriate structure type. I truly hope that this has been beneficial. Again, my name is Joe Hedrick. Thank you, everyone, for attending the Elevate event, and happy modeling.